Hello there. Welcome to today's episode of Jillian's 0% reasonable functionality before caffeine. But today we make it mathematical. All right, so the overall objective is to find out how fast the height of like the coffee level in the mug is rising as I'm pouring it in. So I'm gonna go ahead and like guesstimate based on like previous problems that I've done involving like water level and everything. If you're pouring into like just pouring in water into a vessel, that's like 50 centimeters cubed per second. So we're gonna go with that one. As for the radius, I'm gonna measure my trusty little mug. I tried to pick one that was as like cylindrical as possible and didn't have a whole lot of like convex, you know, bottom to it. So that would be a radius of 2 inches. And then I'm gonna convert that into centimeters because that will make it align with the calculations and make sure we have the correct units. All right, so we found out our radius is going to be 2 inches. And then I did the math on that, and that's going to be, it's actually gonna be 5.08 centimeters, but we're just gonna go with 5 centimeters because that will make much easier calculations. And then our change in volume with respect to time, as I had estimated, would be about 50 centimeters cubed per second. So we're gonna go with that. And those are going to be our starting measurements. Now what we're looking for is going to be our change in height with respect to time. And then that's gonna be our unknown. And then a formula that we can use is volume for the cylinder, and that's going to be essentially the area of the circle times the height. And an area of a circle is going to be pi r squared. So when we just plug that in, it's going to be pi r squared h equals v. Now what do we already know? We already know the radius. So pi 5 centimeters squared h is essentially just going to be 25 pi h. Are you helping? Hi. No, I think you just want the coffee. Okay. All right, and so when we take the derivative, it would be dv over dh. We're taking it with respect to h, so since we're assuming that just has like a 1 on it, it will be h to the 0, so essentially just 1. So we're going to be left with 25 pi. All right, and so you can see dv over dt is essentially going to equal dv over dh times dh over dt. We know that because these are going to cancel out, and we're just going to be left with, oh, sorry, the paper's moving, dv over dt. So that's where we're going to go off of that. So because of that, we can plug in over at the dv over dh, we can plug in 50 centimeters cubed per second equals 25 pi times our unknown variable of dh over dt. And so this is where we begin to actually just algebraically solve. So we're left with 50 over 25 pi equals dh over dt. That's essentially 2 over pi. And then when I did the math on that, I got about 0.637 centimeters per second. I'm gonna put that next to it, but I'm running out of space there. And so that is going to be, oh my gosh, why can't I circle this? There you go. That's going to be the height, or like the rate at which the height of the coffee is rising. And that's what we were solving for to begin with. And now I just sit back, enjoy my coffee, become functional.